Okay, so we have acid and bases review. Make sure you have your reference table out and your calculator. All right, number 1, which compound dissolves in water to form an aqueous solution that conducts an electric current? So this is electrolytes. So electrolytes are acids, bases, and salts. So make sure you look at table K or L to find anybody who's on those. So if I'm looking at table K, which is the acid chart, you can hear me turning to it. I do see CH3COOH. That is another way of saying acetic acid. This is an alcohol. This is an organic compound, and so is that. So get rid of those. As water is added to a 0.1 molar NaCl aqueous solution, the conductivity of the resulting solutions, well, we are diluting something, which means the concentration will decrease. So will the conductivity increase or decrease? Well, it'll also decrease because it's less concentrated, so it's going to be more dilute, fewer ions. A substance is classified as an electrolyte if it is, it conducts an electric current, but it has to be aqueous. A student tested a 0.1 molar aqueous solution, made the following observations. Conducts electricity, okay, so it's got to be an acid, base, or salt. Blue litmus turns red, so that's going to be on table M, and reacts with zinc to produce gas bubbles. So let's see if we can eliminate anything from the choices. This is not an acid. Ooh, it could be a salt. Get rid of that. This is an organic alcohol. And so now we have, this is an acid, this is a base, and this is a salt. Salt is an ionic compound. Okay, so blue to red is acid. And also, if you look, litmus turning red would be a pH of 4.5. So that's acid. So who is an acid? That's choice 3. Which is a non-electrolyte, so not an acid, base, or salt. So anything on table K, which I see, this is nitric acid, this is sulfuric acid, this is sodium hydroxide, that's on table L. So that last one, which is called an alcohol, which is the best conductor of an electricity. So we want ionics, and then you want aqueous, immobile ions in solution. Arrhenius theory explains the behavior of acids and bases. Arrhenius acids and bases. Arrhenius acids is anything that produces H plus in solution, and Arrhenius base is anything that produces hydroxide or OH minus. So an Arrhenius acid, again, table K. And you will see this one right here. H3PO4 is phosphoric acid. Arrhenius base, table L. What's going to produce OH. So again, these last two have OH, but only choice 3 is a base. This is an alcohol. Alcohols are organics ending with OH. All right, number 10. Which ion is the only negative ion produced by an Arrhenius base in water? Has to be hydroxide, OH minus. According to the Arrhenius theory of acids, citric acid in oranges and acetic acid in vinegar are classified as acids because their aqueous solutions contain hydrogen ions, H plus, not just H, and definitely not anything having to do with OH. What is the pH of a solution that has a hydronium ion concentration? Well, by the way, hydronium is on table E. That is essentially H plus aqueous. So notice how we've got the water molecule in here. So we're talking acids. So it says a stronger acid because it's 100 times greater. So on the pH scale, if you're at a 4 and you want to be 100 times greater acid, we're moving down. Each jump on the pH scale is worth 10. It's logarithmic, so we're going to choose choice 2. 100 times greater than 4. Each jump is worth 10. As the pH of a solution has changed from 3 to 6, okay, so we're still talking about hydronium. So hydronium is acid. When you go from 3 to 6, you're becoming less like an acid. So they're going to decrease. And so 3, let's call that a 3 to 6. So that's 10. 10 times 10 is 100. 10 times 10 times 10 is 1,000. So it's going to decrease by a factor of 1,000. Each jump is worth 10. We've already talked about 14. An hydrogen ion in aqueous solution can also be written as H3O+. Which statement correctly describes a solution with a pH of 9? So pH of 9, I already know that's a base because I know my basic pH scale. So a base would have more hydroxide than hydronium. And what happens with litmus? Blue to red acid. Red to blue is base. So litmus will turn blue. Methyl orange turns red in a low pH. So that's not it. This question, everybody gets wrong, and it's because you just got to read it. Given the following solutions, increasing H plus becomes more acid. So you want to go down in numbers. So A, B, C. As an aqueous solution becomes more acidic, what happens to the hydroxide ion? So more acidic means more H plus, so less OH minus. pH of 7 means you've got equal amounts of hydroxide and hydrogen ion. So choice 1. Okay. Number 19. I don't believe we're going to do that one this year, but it is choice 1 basically because W is water and you'd have neutral. So we won't need to worry about 20. 21. No. 22, no. And 23, no. The pH of a 0.1 molar CH3COOH solution. Okay, so what the heck is this? Is it on table K? It is. It's called acetic acid. So it's an acid. So the pH of an acid is less than 1, greater than 1 but less than 7, equal to 7. Well, I know that is water. Greater than 7 is base. So less than 1, no, that's not super strong. It's just vinegar. There we go. An aqueous solution, we're not doing that one. This is table M26. Which indicator is blue in a solution that has a pH of 5.6? Okay, so table M, brome cresol green. If you are 5.6, that is, you know what? Let me go to actually this. Let me just show you. Here we are. Okay. So it says brome cresol green 5.6. So 5.6 is on this side, so it's blue. Brome thymol blue 5.6 is this way, so it's yellow. Methyl orange 5.6 is this side, so it's yellow. And thymol blue 5.6 is this side, so it's yellow. So the one that is blue is brome cresol green, choice 1. Let's go back to where it was. Here we go. Brome cresol green. Which indicator is yellow in a solution? Okay, here's another table M. Let's go there. So I'll erase this stuff. Okay. Okay, so yellow, pH 9.8. Methyl orange, 9.8 is up here, so that's yellow. That's probably our answer, but let's keep going. Brome thymol blue, 9.8 is this. It's no blue. Brome cresol green, 9.8 blue. And thymol blue, what is it? 9.8 blue. So methyl orange, choice 1 again. Okay. According to table M, what color in the indicator? Methyl orange is pH of 2. So pH of 2. Okay. Methyl orange, pH of 2. Okay. So 2 is down here, which means it's red, which is choice 4. Sorry to dance between these. Okay, choice 4. Solution with a pH of 11 is first tested with phenolphthalein and then litmus. What's going on? pH of 11. pH of 11. Oh, goodness. Okay, pH of 11 in phenolphthalein would be up here, which would be pink. pH of 11 in litmus would be up here, which would be blue. So phenolphthalein is pink and litmus is blue. I believe that's choice 3. Yep. A student dissolves substance in water, tests the resulting solution, and red turns blue. This is a base. First of all, you're only going to have acid or base anyways. Which particle in a water solution of NaOH causes red litmus to turn blue? So you could only have Na plus and OH minus, and it will be OH minus. Okay, we got Bronsted-Lowry acids and bases. So the H plus acceptor for the forward. So here's what I do. I say NH3 becomes NH4. What happened? It must have gained a proton. So there it is. It's NH3. The alternate theory is Bronsted-Lowry. H2O is a base when it... So Bronsted-Lowry acids accept and base donate, and it will be protons. So that is what? Choice 4. This is choice 2. What describes the behavior of H2O? Okay, so in the first one, H2O becomes OH minus, so that is losing protons. In the second one, H2O becomes H3O plus, which is a gain of protons. So it can't be both. Water acts as an acid in reaction X, which is losing, and a base in reaction Y. That is correct. That's the definition of Bronsted-Lowry. 35, basic solution. So if you're basic, you have to have a greater OH minus solution. Amphoteric means it can either be Bronsted-Lowry acid or base. And this is honors reference table L. Yeah. So you would go to honors reference table L. No. And you'd say, okay, somebody's who's on both sides. H2S. Here it is here. I don't see H2S on the other side. HS minus. Here is HS minus. Here's HS minus. See how it's on both sides, the acid and the base side? That makes it our answer. I'm not going to keep going because I just know that's my answer. Given the reaction, what is the conjugate acid-base pair? So look for the only difference is a proton. So NH3 gas and NH4, choice 4. Neutralization is acid plus base yield salt and water. So can't be these, it can't be that. The only one with acids and base to start. As an acid solution is added to neutralize a base solution, the OH minus concentration of the base, it will go down. Because you have a lot of OH minus in a base, and you're adding acid, it will decrease. A salt is anything ionic, so nothing on table K or L. This is an acid, table K. This is an acid, table K. This is a base, table L. Number 1 is, we've got the charges. Okay, now we have titration. MAVA equals MBVB. Which volume of 0.1 molar NaOH? So that's our base. So this is 0.1. Exactly neutralizes 15 milliliters of 0.20 molar. And this is 15.0. And this is, call it X. So 0.2 times 15 is 3 equals 0.10 times X. So divide both sides by 0.10 is 30. Choice 4. A student wishes to determine the concentration of a weak acid by titration with a base of known concentration. What is the most important property of the base? It doesn't need to be weak or strong, but we do need to know its molarity in order to use this formula. Here's another titration. A 16 milliliter sample of 0.5 molar KOH. So that is our base sign. Will completely neutralize 32 milliliters of what? 16 times 0.5 is 8 equals 32x. Divide both sides by 32. And you get 0.25 molar, which is choice 4. That is a 4. Here we have a titration. read it. NaOH being added to HCl. A few drops of phenolphthalein were added. The endpoint is reached. Okay, so the only color change for phenolphthalein is either colorless or pink. But we're adding NaOH, so that we're adding base, which means it's going to turn pink. We have another titration. 9 milliliter sample of HCl is exactly neutralized by 6 milliliters of 3 molar, so I don't know that. So this is 18 equals 9x, divide both sides by 9, and you get 2 molar. All right. Here we have short answer. So it says, show a numerical setup for calculating the concentration of the hydrochloric acid using titration data. Okay, so you don't have to solve it. In a lab activity, a student titrates a 20 milliliter sample of HCl using 0.25 molar NaOH, so that's our base. In one of the trials, 17.6 milliliters of the base solution exactly neutralizes. So you can do that. You can call it X if you want. Doesn't matter. And you don't need to solve it. So identify the positive ion in the sample of HCl. So this is an acid, so you can say H+, you can say H3O+, you can say hydrogen ion. You can't say hydrogen. You can say hydronium. Okay, student is to determine the concentration of NaOH by solution, 2 different titrations. Okay, blah, 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 blah. Okay, so there's a graph. I shouldn't say blah, 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 but you know how it goes. Complete the equation below for the neutralization that occurs. Okay, so acid plus base yields salt and water. So, and it's a double replacement. NaOH, Na plus, OH minus, H plus. Okay, so goodbye to this and this, so we have Na and an SO4. However, you have to crisscross your charges. You get Na2SO4. That is your answer. Based on the graph, determine the volume of NaOH used to exactly neutralize the HCl. Okay, so exactly neutralize. We said, okay, so it says 25 milliliters. Hold on a second. The volume of that exactly. Okay, so neutralize means pH of 7. So come over here. Come down. 25 looks good. The answer key says 24 through 26, but I don't see how you could be anything besides 25. State the color of phenolphthalein indicator if it was added after the HCl was titrated. So you're adding NaOH, so the phenolphthalein is going to turn pink. It would be colorless in acid, but we're adding base. Okay, here we go. Okay, so you should read that. A sample of seawater has a pH of 8. Determine the new pH of the sample if the hydrogen ion concentration is increased by a factor of 100. So that's 2 jumps, because each jump on the pH scale is worth 10, and we're becoming more acidic because hydrogen ion is increased. So if it starts at 8, we're going to go back. 8 goes to 7, goes to 6, pH of 6. There's no give or take with that. State the color of brome cresol green, a sample of seawater, while the CaCO3 solubility is 10 to the minus 2. So 10 to the minus 2. So here we go. Looks like 6 point, I don't know, almost 7, 6.5, I don't know. So let's go to table M, which I'm going to just look at mine. I don't want to keep flipping back and forth, but you should be looking at table M. Brome cresol green. And now 6.5 or whatever it is definitely above the high end of the range, because it says 3.8 to 5.4 yellow. Oh my gosh, yellow to blue. So 6.5 is way over here, so it's going to be blue. State the trend in solubility as the seawater becomes more acidic. So the solubility, now let's see. More acidic, the solubility changes. So as it becomes more acidic, be careful. More acidic means pH goes this way. So if the pH goes that way, the solubility will increase. And that's a tricky one because everybody's going to say, oh, it goes down because, you read the graph left to right. But we're becoming more acidic, so we're going to have to go backwards. All right, vinegar is a commercial form of acetic acid, and it has a pH value of 2.4. Explain in terms of particles why it can conduct an electric current. As with any electrolyte, we have mobile ions, ions in motion, freely moving, and that's what allows electric current to pass through. During a titration, 10 milliliters of acetic acid is completely neutralized by adding 12.50 milliliters of a 0.64 molar sodium hydroxide. Explain why it is better to use data from multiple trials to determine the molarity rather than one. You're going to have fewer errors. You're going to have a greater sample size. Improve precision. Remember, precision means the repetition or reproducibility. So you definitely need to do it more than once. All right, so here we go. We have a titration, maybe. No, we just have comparisons of the concentration of an acid and your pH value. Determine the volume of a 0.25 molar NaOH solution that would exactly, okay, so this is titration. So this is base, so 0.25 molar, and we're looking for the volume of the base. 75 milliliters of the acid, 0.0, and solution X has a concentration of 0.10 molar. So 0.10 molar times 75 is 7.5 equals 0.25x. So divide both sides by 0.25, and you get, I got 300. That's not what the answer key says. Where did I screw it up? 0.1, 75, 0.25. Well, the answer key says 30 milliliters. However, I got 300. Let me check this again. Let's see. 0.1 times solution X. Yeah, 75. 7.5 divided by 0.25. Oh, now I got 30. I'm just a fool. It is 30 milliliters. Determine the concentration. Hold on a second. Bless me. Determine the concentration of an HCl solution that has a pH value of 4. pH value. Okay, so look. We have a 0, 1, 2, and 3. Every time we get bigger pH value, we're going to move our decimal place one more spot to the left. So pH value of 4, this is a 3. This is 3. So move it one more to the left. So you're going to get 0.00010 molar. So could you also say that in scientific notation? Sure, that would be 1 times 10 to the minus 1, 2, 3, 4. Say the number of sig figs in solution Z. So again, only those last two. Concentration, okay, this is titration, 25 milliliters of HCl, and I don't know that, and 15 milliliters of 0.20. 15 times 0.2 is 3 divided by 25. Whoops, 3 divided by 25 is going to give me 0.12 molar. Based on the data, how many sig figs? Okay, so up here we have 3 sig figs, 3 sig figs, and 2 sig figs. So 2 sig figs. Complete the neutralization. Okay, so acid plus base always yields a salt and water. So here's water. It's a double replacement. So goodbye, and so there it is. Got to have Na first because Na is positive. And finally, what's the lab procedure? It's called a titration. Titration. All right, if you have any questions, please reach out. Thank you.